In this video lecture, we are going to discuss about Coulomb's law. Just when Coulomb's law tell us about the magnitude or amount of force between 2 point charges present at rest. Or we can say that Coulomb's law tell us about the magnitude of attractive or repulsive force between 2 point charges which are present at rest or which are present at static position. So we can write that Coulomb's law tell us about magnitude of attractive or repulsive force between 2 point charges when they are placed at rest or at static position. The word static also means rest. So the branch of physics in which we study charges present at a rest is known as electrostatic. Electrostatic is a combination of two words, electro, which mean charges, plus word statics, which mean rest. So branch of physics in which we study about the charges present at rest is known as electrostatics. So Coulomb law is also based on a force on amount or is based on magnitude of force between 2 point charges present at rest. So this is the reason, because of that Coulomb law is also known as Coulomb's law of electrostatics. So this means that we study Coulomb's law in electrostatics. Students, there are two types of charges. One type of charge is known as positive charge, and other type of charge is known as negative charge. Since you know that in a magnet has two poles. One pole is known as north pole and second pole of magnet is known as south pole. And these north and south pole have magnetic field of line associated with them, and the magnetic field of line basically goes from north pole toward the south pole like this. And similarly, magnetic field of line come inward toward the south pole. Whereas in North Pole, the magnetic field of lines goes outward from a North Pole. So the number of magnetic field of line basically is known as a magnetic flux, or it is known total number of magnetic field of line passing through an area is basically known as magnetic flux, and the amount or magnitude of magnetic field of line is basically known as magnetic field intensity. Similarly, in positive and negative charges, there are electric field of lines. These are basically imaginary field of lines. They are present between positive and negative charges. Electric field of line in positive charges are directed outward like this. Similarly, electric field of line in negative charges are directed inward like this. Let me clear it. They are directed inward like this. So now, as you know that the basic principle of physics that the like charges, suppose we have positive charge, two like charges repel each other. So these charges will repel each other. Similarly, two unlike charges like positive charge and negative charge, these charges attract each other. These charges attract each other. And whereas these charges repel, opposite charges repel each other. So now question here is that why same type of charges, these charges, same type of charges plus and plus repel each other, or negative and negative repel each other, and why opposite charges like plus and negative attract each other? What is the reason of that? Reason is quite simple, dear student. The reason is quite simple that if we take a positive and negative charge, positive charge have associated imaginary electric field of lines. These electric field of lines are directed outward, whereas if we take a negative charge, the electric field of lines come toward inward. So the electric field of line going from positive charge, which is outward, will go toward the inward. So both of these will combine, and due to combination of these imaginary electric field of line in the same direction, they will result into an attraction between them. Similarly, in case of electric charges, same electric charges, let us give me an example. In case we have, suppose this is a negative charge and electric field of lines are coming inward, inward like this, inward like this, inward, inward. That make me wrong, it's round, inward. Electric field of line is inward, 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 and inward. So now, if you see the direction of both electric field of line is basically inward, which means that there will be a repulsion between these electric field of line, and repulsion will basically result into separation of these charge particle away with a specific force. So now here we have positive and negative charge, so they have an attraction between them, and on the other, whereas the same charges like negative charges, they have a repulsion with each other. So now important question here is that what Coulomb law tell us? Basically Coulomb law tell us about the force F. Basically it tell us about the force It tells us about the force between the positive and negative charge at a static position or between a same charges. They could be positive positive or negative negative, and the charges are at static position. So basically Coulomb law tell us about the magnitude of force which basically is applied by this positive charge on negative charge or this negative charge on positive charge. Similarly, it can also tell us about the magnitude amount of force applied by this negative charge on this negative charge or this negative charge on this negative charge. So on the basis of Coulomb law, we basically can calculate the amount of force of attraction between 2 point charges which are present at a static position, or with the Coulomb law of electrostatic, basically we can also calculate the amount of force of repulsion between the same charges. Now this will let us write the statement for the Coulomb's law of electrostatics. Basically, if the Coulomb law of electrostatics states that the magnitude of electrostatic force between 2 point charges is directly proportional to the magnitude of charges, to the product of magnitude of charges, and inversely proportional to the square of distance between them. So let us write the definition of Coulomb law of electrostatics, or statement of Coulomb law of electrostatics. Coulomb's law states that the magnitude or amount of electrostatic force between 2 point charges is directly proportional to the magnitude of product of charges and inversely proportional to square of distance. Let me clean. Square of distance between them. So this will let me elaborate the Coulomb law of electrostatics. Coulomb law electrostatics states that the magnitude or amount of force between 2 point charges when they are at rest is directly proportional to the magnitude of product of charges and inversely proportional to the square of distance between them. Suppose that we have 2 point charges. Suppose that this is 1 point charge, suppose this is positive charge, and this is also positive charge, and these charges are separated by distance r. Okay, whereas the magnitude of the positive charge, suppose we say it is q1, and magnitude of positive charge 2 is q2, or the amount of positive charge, this amount of positive charge is q1, whereas amount or the magnitude of positive charge is Q2. These charges are separated by a distance r, and these charges are present at static position. Suppose these are at static or at rest position. Then what is a force? What is a force which is exerted by these two charges on each other? The force, the charges are at rest, then the law which is applied to know the magnitude of amount of force exerted by this Q1 charge on Q2 or Q2 charge on Q1 is known as Coulomb's law. And as you know that according to the statement of Coulomb law, the magnitude of force exerted between these 2-point charges will be directly proportional to the magnitude of product of these point charges or amount of the product of these charges. So we can write it mathematically that force electrostatic force between these 2-point charges will be directly proportional to the magnitude of charges, these charges, magnitude of product of these charges. So Q1 force will be basically directly proportional to Q1 into Q2. Similarly, Coulomb law states that force between these 2-point charges is inversely proportional to the square of distance between them. So we can write it as force between these 2-point charges is inversely proportional to the square of distance. Distance between these point charges is r. So it will be basically square of distance. So r force will be directly proportional to 1 over r square. Inversely proportional to will be inversely proportional to r square. Will be f will be basically directly inversely proportional to r square. So we will write like this. So now if we combine, suppose we say that this one is equation number 1 and similarly this one is equation number 2. So if we combine equation 1 and equation 2, we can get that force between these point charges is equal to, if we remove the constant, we remove the proportionality, then we have to write constant here is equal to Q1 into Q2 divided by R square. So suppose that this is equation number 3. The constant used in Coulomb law is known as Coulomb constant, and Coulomb constant is represented by capital K. So we can incorporate capital K in equation number 3. So we can basically get a Coulomb equation as F is equal to capital K Q1 Q2 divided by R square. So this will be the force exerted by the 2-point charges when they are at rest position. So dear student, the Coulomb equation is force between two oppositely point charges is equal to K Q1 Q2 divided by R square. K is called the Coulomb constant of proportionality. Please keep in mind that Coulomb constant of proportionality K is equal to 1 over 4 pi epsilon naught. Now, question here is that how the K value, K formula for K is determined, which is 1 over 4 pi epsilon naught. Basically, dear student, Coulombs performed torsional balance experiment, and on the basis of torsional balance experiment, Coulomb concluded the formula for Coulomb constant, which is 1 over 4 pi epsilon naught. Student, please keep in mind that the symbol epsilon naught is known as permittivity of free space. Permittivity of a free space. So we can write Coulomb equation as F is equal to 1 over 4 pi epsilon naught into Q1 Q2 divided by R square. Let us say that this is equation number 1 here. So we basically know that the value of pi is equal to 3.14, and whereas the value of permittivity epsilon naught, permittivity of free space, is 8.85 into 10 raised to power minus 12 Coulomb square per Newton meter square. So from this value, dear student, we can basically determine the value of Planck constant, the value of Coulomb's constant. Since you know that Coulomb constant K is equal to 1 over 4 pi epsilon naught. So if we incorporate the value of epsilon naught, we can get that 1 over 4 into 3.14 into 8.85 into 10 raised to power minus 12 Coulomb divided by Newton meter square. So this Coulomb Newton meter square will come upward. So we can get basically K is equal to, if we do a mathematical calculation, we can get K is equal to 9 into 10 raised to power 9 Newton meter square divided by Coulomb square. So this is a value of Planck constant. So now, dear student, we can also easily calculate the unit of unit of Coulomb constant. Since you know that a force between 2 point charges is equal to F is equal to K Q1 Q2 divided by R square. So K will become force into R square divided by Q1 Q2. So unit of force is Newton, R is the distance between 2 point charge, so the unit of distance is meter, so R square will be Newton meter square, and whereas the unit of charge is Coulomb, so 2 point charges, so the unit of charge become Coulomb's 2 point charges become Coulomb square. So this K will become, the unit of K become K is equal to Newton meter square divided by Coulomb square. So now, dear student, let us calculate a Coulomb force between two opposite charges. Suppose we have a positive charge and as well as a negative charge. These point charges are separated from each other by a distance r. Suppose the distance between them is r. The magnitude of charges are charge on them is q1 and q2. So the minus will point charge will have minus q2, as the positive charge will have a magnitude of charge will be plus q1. And similarly, now we need to calculate a force. Since you know that these 2 point charges are opposite charges, so we need to calculate a force of attraction, F attraction between these point charges. What is a force of attraction between these, what is the magnitude of force of attraction between these 2 point charges? Since you know that according to Coulomb's law, force of attraction or repulsion between 2 point charges is directly proportional to the magnitude, to the product of magnitude of the point charges. And force of attraction or repulsion between 2 point charges is basically inversely proportional to the square of distance between them. Suppose we write this as equation number 1 and this as equation number 2. If we combine equation 1 with equation 2, we can basically get a force of attraction between two opposite charges, which is basically equal to minus Q1 into Q2 divided by R square. If we remove the constant of proportionality, so we can get a force of attraction is equal to constant minus Q1 into Q2 divided by R square. Since, dear student, we know that constant of proportionality is known as Coulomb constant, and Coulomb constant is represented by a K, which is represented by a capital K. So we can write the equation 3 as F, force of attraction between two opposite point charges, is minus K into Q1 into Q2 divided by R square. You know that K is equal to 1 over, let's say, suppose this is equation number 4, and you know that K is equal to 1 over 4 pi epsilon naught. So then we can write this equation as force between two oppositely point charges is equal to minus 1 over 4 pi epsilon naught into Q1 Q2 divided by R square. So this is called a Coulomb equation for two opposite point charges. So now, interesting question here arises is that this equation is have a term you known as constant of proportion permittivity, or have a constant known as permittivity of free space. Permittivity of free space. Now, in some cases, if we have a different medium present between these 2 point charges. So now let us consider the condition in which there is a different medium present between these 2 point charges, then what will be the magnitude or what will be the amount of force between the point charges. Suppose, a dear student, we have a same charges, suppose we have a positive charge and another charge is also positive charge. Magnitude of magnitude of positive charge is plus Q1, and magnitude of on amount of charge on second charge is plus Q2. Okay, the distance between these two positive charges is suppose is R. Okay, so now if there is a medium, suppose this is a medium or this is a medium or anything present between the point charges, between these positive and negative charges, then in such situation, what will be Coulomb force between these 2 point charges, between these two positive charges when they are at rest? Since you know that according to Coulomb law, the force of attraction between 2 point charges is directly proportional to the magnitude of the amount of the product of point charges. And similarly, force of attraction or repulsion, here it is repulsion, so the force of repulsion of these point charges will be inversely proportional to the square of distance between them. If we combine, so we can get a Coulomb equation as F is equal to K Q1 Q2 divided by R square, and we can, you know that K, value of K is equal to 1 over 4 pi epsilon naught. So we can basically, for which epsilon naught is a permittivity of free space, so we can incorporate the value of permittivity of free space in this equation. So we can get Coulomb equation as F is equal to K, sorry, let me clean it. F is equal to 1 over 4 pi epsilon naught into Q1 Q2 divided by R square. So now question arises here is that, suppose let me say it as equation number 1. Question here arises is that we have a medium medium between this plus q and plus q1 and plus q2 charge. So this medium will basically act, and this medium will basically decrease the force of repulsion between these two same charges. So due to this, another term will be used which is known as relative permittivity. So another constant ER will be incorporated in this equation 1. Since you know that the medium is present between these two charges, so the medium will basically decrease the force of repulsion between these 2 point charges, which means that the force Coulomb force will be inversely proportional to the relative permittivity. So we have write the relative permittivity in denominator of equation number 1. So the equation number 1 will become F is equal to 1 over 4 pi epsilon naught into epsilon naught R into Q1 Q2 divided by R square. So whenever there is a medium whenever there is a medium present between the two charges which are present at a static position, which are present at rest, then the force of attraction, or then the force between these 2 point charges will depend on the medium also. Sorry, this is ER, let me write it ER. It will depend on the permittivity of that medium ER. So in this situation, the force of medium which is basically decreasing the force, so this will be less than the force which is present in a normal vacuum where we have applied a permittivity of free space. Or in general, we can say that, let me write it, F is equal to 1 over 4 pi epsilon naught into Q1 Q2 divided by R square, which is basically a force exerted by a point charges when they are placed in a vacuum, or when there is no medium. It will be greater than the force which will be 1 over 4 pi epsilon naught into epsilon naught R into Q1 Q2 divided by R square. So this force of vacuum, which is force of point charges which is placed when they are placed in a vacuum, will be greater than the force of a point charges when there is a medium placed between them. Medium is basically blocking, or it is decreasing the amount of force, which means that force on medium will be less than the force of the vacuum or between the 2 point charges. So now let us calculate the force of attraction between two oppositely point charges when there is a medium present between them. This one, suppose that we have two opposite point charges. Suppose this is plus point charge and this is negative point charge, and the amount of magnitude of charge on them is plus q, and magnitude of charge on negative charge is negative q, and the distance between these 2 point charges is r. Now these charges are initially at vacuum. If we place a medium between them, then suppose this is a medium or anything present between them, then what do you think, what will be a force of attraction between these two opposite charges? What will be a Coulomb force? What will be Coulomb force between these two opposite charges? Since you know that according to Coulomb law, the force of attraction for these charges is equal to magnitude of is basically directly proportional to the magnitude of charges or amount of product of charges, and inversely proportional to the distance between them. So Coulomb force will become, if we combine these two equations, Coulomb force will become F is equal to constant into, we can write minus here. Sorry, let me clean it. So we can basically write minus here into Q1 Q2 divided by R square. So now you know that Coulomb constant of proportionality is K. So then Coulomb force will become, between two opposite charges, will become K Q1 Q2 divided by R square. Let's say this is equation number 1. And dear student, you know that K is Coulomb constant and it is equal to 1 over 4 pi epsilon naught. We can incorporate this value of K in equation number 1. So we can basically get force of attraction between two opposite point charges is equal to minus 1 over 4 pi epsilon naught into Q1 Q2 divided by R square. So now this is equation for two opposite point charges when there is no medium between them. However, we have a placed medium between these two opposite point charges. Then the force of attraction between these two opposite point charges will become F is equal to 1 minus 1 over 4 pi epsilon naught into epsilon naught R, which is a relative permittivity, into Q1 Q2 divided by R square. So basically this will be a force between two oppositely point charges whenever there is a medium between them. Relative permittivity constant ER is also known as dielectrics, or it is also known as dielectric constant. This dielectric is basically it has no unit, and it is a ratio of force. Dielectric or permittivity is basically, it is relative permittivity is basically, it is a ratio of force between a point charges in a vacuum divided by force between a point charges in a medium. So this is basically a ratio of same quantities. So since you know that unit of force is Newton, so Newton will basically cancel Newton, and the unit of relative permittivity will be just it will have no unit, because the force and force cancel each other. So dear student, in general, we write a Coulomb equation as F is equal to 1 over 4 pi epsilon naught into epsilon naught R, which is relative permittivity, into Q1 Q2 divided by R square. This is general equation for a Coulomb equation for a charges for opposite for a same charges and having a medium between them. So now if we take out the relative permittivity from this equation, and we just write remaining equation as 1 over 4 pi epsilon naught into Q1 Q2 divided by R square. Since you know that this force is basically force with for when there is a medium place between the two same charges. So this is force for a medium. So whereas force for vacuum, Coulomb force for vacuum, suppose this is equation number 1, Coulomb force for vacuum is 1 over 4 pi epsilon naught Q1 Q2 divided by R square. So then the equation number 1 will, if we incorporate the value of equation number 2 in equation number 1, then equation number 1 will become F force of medium is equal to 1 over relative permittivity into force at a vacuum. So then the value of relative permittivity epsilon r will become force of a medium divided by force of a vacuum. So this means that both the unit of force is Newton and Newton. So the Newton and Newton will cancel, which means that the value of relative permittivity, the unit of relative permittivity will be no. So there will be no unit of relative permittivity because the uh, force and force are same quantities, and the unit of same quantities will cancel each other. So due to this, the unit of permittivity, there will be a no unit of permittivity, a relative permittivity, and the relative permittivity is basically known as a dielectrics of a medium. So dear student, this is all about Coulomb's law of electrostatic. Coulomb law of electrostatic basically tell us about the magnitude of amount of force between 2 point charges when they are present at a static or rest position. The Coulomb force equation for a Coulomb force is basically depend on a medium. If there is no medium present between the point charges, then the Coulomb force will be just 1 over 4 pi epsilon naught into q1 q2 magnitude of charges divided by r square. Whenever there is a medium present, then we have to incorporate a relative permittivity in a Coulomb equation. Relative permittivity is also known as dielectric constant, and it has no unit because it is a ratio of force of Coulomb force between the charges when there is a medium to the ratio of Coulomb force when there is no medium present between the point charges. So this is all about Coulomb's law of electrostatics. So dear student, thank you for watching this lecture.